Okay, so today I'm going to be solving the final question on the first test for the physics exam. So the first part is to identify which ball, the left or right ball, is positively charged. So because the electric field is pointing in the left direction, that tells us that the right ball is positively charged because electric field points away from positive charge and towards a negative charge. So the ball on the right is the positively charged um, ball. So for part B now, we have to find the magnitude of the electric field. So the first thing we want to do is apply the equilibrium of the balls, right? So that means that it's going to be coming down the middle. So this is given by the equation T cosine of 1/2 of the angle is equal to mass times gravity. So we are solving for the tension force. So it's going to be T is equal to mg over cosine of 1/2 of theta. And plugging that in is going to give us 6.8 times 10 to the minus 6 times 9.8, which is our value for gravity, times cosine of half the angle, which the angle is 58, so half of that would be 29, and that is going to give us a value of 7.619 times 10 to the minus 5. Let me write that 5. So this is one part of our force. Now to get the other part of our force, we want to use this equation here, which is our regular force equation of Q1, Q2. In this case, it would be the same, so it would just be Q squared over R, which over R squared, which for this purpose would be represented as 2 times the distance squared. So plugging that in is going to give us 8.99 times 10 to the 9 times Q, which is 72 times 10 to the minus 9 over 2 times the length, which in this case would be again represented by half the angle. So it would be your length of your wires, which is 53 times sine of half the angle, which is 29 again, and all of that is squared. Sorry, I forgot. This charge up here is also squared. So by multiplying that all out, we get a value of 2.32, or sorry, not 2.32. It would be 1.75, 1.75 times 10 to the minus 4. So we now have both of our force values. So to get the force total, we just add them up. So it'll be 1.75 times 10 to the minus 4 plus 7.619 times 10 to the minus 5, which is going to give us a total force of 2.509 times 10 to the minus 4. So we can now plug that into our force equals EQ equation. In this case, it would be E, which is what we're solving for, is equal to force over Q. So E would be equal to 2.509 times 10 to the minus 4 over the charge, which is 72 times 10 to the minus 9, And that is going to give us a value of 3.484, which if you round it up would actually be 3.485 times 10 to the third. And this value, of course, is in newtons per coulomb, as that is the value or the unit of measurement for electric field. And that's how you solve it.